Okay, so in section 3.1, we're going to talk about complex numbers. So you may have seen some of this before, so some of it will be review, and then we're going to expand our knowledge a little bit with some ideas. Okay, so I know it says complex numbers, but maybe they're not all that complex. So I kind of like them. But all right, say you have this equation, x squared plus 4 equals 0. Well, you could write x squared equals -4, and you can take the square root of both sides, something like that, to solve the equation. Well, then we have a problem, because the square root of -4 is not a real number. This is not a real number, and that's still true. We've been working with real numbers, but the square root of -4 is not real. If you think about this equation, there's no number you could put in for x, square it, no real number that you can put in for x and square it, add 4, and get 0. So we have to expand our concept of numbers and go beyond what we call the real numbers. Now, the real numbers have worked very well for a lot of years for most people, and now we're at a point, though, where we need to introduce a new set of numbers. Complex numbers can be written in the form a plus bi form. This is standard form. A represents a real number, and bi represents the imaginary number. Okay, so let me go back to where we had the square root of -4. You may remember that we write that as 2i. Okay? Now, that's not the solution to this equation. I mean, you'd have 2 plus 2i and minus 2i, but anyway, that's how it's defined. So the square root of -1 is represented by the letter I. It's a italicized I, lowercase. All right? So that is how it's defined. You can think about the square root of -4 as being the square root of 4 times the square root of -1, and then that part is the I, and then the square root of 4, we know that is 2. Okay? So that's how these complex numbers are working. We'll do a little bit of that. They talk about, in the book, they talk about complex numbers being when you are taking an even root of a negative number. However, I represents the square root of -1. So try to remember that. Okay, so put like a little box around this in your notes. We're going to talk about more complex numbers later on, but we need some trigonometry to do that. Okay, so just hold on to that nugget of information for right now. The square root of -1 is equal to I. Okay, now back to my standard form here, a plus bi. So you have this real part, and then I represents the imaginary number portion. Okay, so the square root of -1 is an imaginary number, and we represent it with I. Okay, so you could have the number 7 plus 2i. The real part would be the 7, and the imaginary part would be 2i. All right? You could have an imaginary number that's -5i. The real part would be 0. The imaginary part would be -5i. All right. Both a and the letter b are real numbers. So it's just the I that brings in the imaginary part. Okay? You could also have the number 8. 8 is considered a complex number. A is the real number, and b is 0 this time. You could write 8 plus 0i. Sometimes we want to do that, not very often, but you could. So there's a real number portion, and then there's this other portion, the imaginary portion, which has a real number coefficient, and then the I to represent the imaginary portion. All complex numbers can be written in a plus bi form. Okay? Okay, I think I've said everything I want to say on that. So let's just look for a minute at sets of numbers. You know, you have your natural numbers, 1, 2, 3, 4, and so on. You have your whole numbers, which are 0, 1, 2, 3, and so on. You have your integers, which are -3, -2, -1, 0, 1, 2, 3. Okay, oops, continuing. I don't know what that little blob is. Okay, and these sets of numbers have worked very well for you. You probably started out learning the natural numbers, and then around kindergarten they added 0, the concept of 0, and then somewhere they said, hey, we can have negative numbers, and then you had the set of integers. Then you had rational numbers. Let me switch. Rational numbers. And we can't list the rational numbers, but they're basically any number that can be written as p over q, where p and q are integers. So, you know, your fractions, 3/5, 10 over 2, or, you know, 10 over 7, or your decimals, your repeating decimals, your terminating decimals, those are all rational numbers. Then we had irrational numbers. Oops, misspelling irrational. Maybe before I talk about the irrational numbers, all integers are rational numbers. All whole numbers are integers. All natural numbers are whole numbers. So they're subsets of each other, okay? But then we kind of draw the line here where we have irrational numbers. Irrational numbers are like pi, e, square root of 7, square root of 2, and we can't list them. These are just examples, but those are numbers that go on and they don't repeat. So you can put them in the form of a decimal, but they go on and they don't repeat. Okay? That's kind of my definition. The rational numbers and the irrational numbers. Now, either you're a rational number or you're an irrational number. You can't be in both sets. You're one or the other. But if you take all the rational numbers and all the irrational numbers, you get the set of real numbers. Okay? Now we have this new set. So how does that fit in? The complex numbers are all the real numbers. So all those real numbers are fitting into that group. And then you also have complex number or imaginary numbers. Okay? So anything where a plus bi, where where b is not 0. Okay, so if there's an imaginary part, then it falls into the set of imaginary numbers, and it is a complex number. So don't forget that all real numbers are also complex numbers. Okay, so it's easy to forget that. Okay, when we have a number like 4i, that is said to be, and the a is 0, that is said to be a pure imaginary number. So sometimes you'll see that. It doesn't have a real part to it. Okay, so that's a pretty long video, but it gives you an idea of the set of numbers that we're working with now, complex numbers.